My dear students, how you all are doing? Hopefully you are doing fabulously fantastic. So are you able to view me properly? I'm just confirming it from my side. So today being the sixth session on solving the problems from 2016 to 2020 papers, and today I will be focusing on majorly on ray optics. Now, ray optics happens to be one of the high weightage chapter with reference to Karnataka CET, my dear students. So, hopefully, you all are well aware about that. Okay. So, today we will focus clearly on ray optics chapter. Okay. So, hopefully, you are preparing very nicely for your forthcoming examinations. Okay, so your pre-university board exam or class 12th exam, as well as the Karnataka CET exam and many other entrance exams you might be preparing for, and I in advance wish for everyone a very happy preparation time. Okay, now let's take a look at today's things what we are supposed to have. Okay, fine. So first and foremost thing, I would like to introduce myself. My name is Uttam Kumar Umarji. I'm verified physics educator on Unacademy YouTube live platform. Talking about my brief profile. So I started my career at various locations. I started my career at Kota initially. I've taught for JEE Advanced, JEE Main Physics closely for about 19 years. Okay, at Delhi, Bangalore, and all across India, almost every place in India, I've taught. Now, I've taught closely to 10,000 plus students till date. So, this is sixth month on Unacademy. I'm sorry, I had gone for a gulp of water. Hopefully, you all are intact here. Okay, so let's move on with our further discussion here. So let us together say, let's crack Karnataka CET with Unacademy. Now here, I would like to say, get your subscription today itself, immediately, and you can very well go ahead and win over Karnataka CET well in advance. If you think of like going ahead with KCET plus subscription, then think that you have already won half of the battle. Now, you can use UTTAMLIVE as your referral code for 10% off. Okay, fine. Now let's begin our further part of discussion. I would like to tell you regarding Unacademy Plus subscription plan. Now here, dear students, if you are planning for Plus subscription, now this is the right time. Now you should think about it. Act wisely now itself. You just go ahead and grab this opportunity. And then why I'm saying this, because on Unacademy Plus platform presently we are 20 plus top educators. Okay, we are extensively training you people. We are there for students, and there are 10 plus batches which are in progress, and 250 plus courses are there. Then 2000 plus lessons have been uploaded already, and many more lessons will get added day in and day out. Now this is where I would like to say Unacademy is the right platform for you all. Now let me just talk about benefits of plus subscription. Now plus subscription, why you have to take? Now that I have answered. Now what benefits you can get out of it? First and foremost thing, you can get a premium content at a very much affordable price. Then you have structured live courses with dedicated live doubt clearing sessions. Then you will always get quizzes at regular intervals for your self analysis. Then there are batches for complete preparation, my dear students. Then we have test series for daily practice papers we have. Then full length mock papers we have with complete analysis you will get. Okay, so if you are getting this, what else you require? So single plus subscription for unlimited access. That is what Unacademy is promised you. So I would like to say everything under single plus subscription. Okay, now let me talk about the pricing quickly. Now pricing, presently we have a 1 month plan. Now this 1 month plan is going to cost you 1500 rupee a month. That's all. Act now. Okay, there is no time to think about anything. Go ahead and grab this opportunity. Use UTTAMLIVE as your referral code for availing 10% off. Okay, so this is regarding Unacademy plus subscription. Okay, now let me begin my discussion for today. Okay, now my first question is, a beam of monochromatic blue light of wavelength 4200 angstrom, okay, in air travels in water having refractive index of 4 by 3. Its wavelength in water will be, okay. Now over here wavelength in water has been asked to us. That's all. Okay. So here the simple logic would be what? We know that refractive index mu is inversely proportional to wavelength. That's all. So if we just adapt this particular concept, we can get the answer like this. Okay, so now let us take a look at the solution. So as I was mentioning to you, mu, that is refractive index, is inversely proportional to wavelength. So accordingly, I can say mu1 by mu2 becomes equal to lambda 2 by lambda 1. Now here our unknown factor is what? Lambda 2. We are supposed to find lambda 2 here. Okay. Now accordingly, I can write this as mu1 is what? Air. Refractive index of air is how much? 1. Okay. And 4 by 3 is refractive index of water. Is it not? So obviously from this I can comfortably calculate the value of lambda 2. So hence I can write lambda 2 from this as 4200 into 3 by 4. That would be 3150 angstrom. Okay. Now 3150 angstrom happens to be option C for us. Okay. So we have cleared this particular question. And let me just tell you once again, this ray optics chapter is the hot favorite chapter for Karnataka CET. So right now I suggest you please be under the mode of preparing for ray optics. Okay, fine. Now let me go to next question quickly. Now, second question. On a glass plate, a light wave is incident at an angle of 60 degree. If the reflected and the refracted waves are mutually perpendicular, the refractive index of the material is. Now, over here, the concept is quite simple. Reflected, refracted waves are mutually perpendicular. That is what they are saying. So clearly, we can draw the ray diagram like this. Now, this is the ray diagram that we are looking for, because angle of incidence is 60°. Hence, angle of reflection will again be what? 60°. And refracted ray is shown here with angle R. Okay. Now, angle between reflected and refracted ray is 90°. That has been marked. Now what we shall do? 60 plus 90 plus R is equal to 180, and hence we can find the value of R from this. Is it not? So hence that is what we are writing now. So 60 plus 90 plus R is equal to 180. Therefore R becomes equal to 30°. Right. Then based on this, next step what I'll do, I'll apply Snell's law at the point of incidence. So obviously applying Snell's law, it is sin I by sin R. Then accordingly sin 60 by sin 30°. That will give me clearly root 3 by 2 upon 1 by 2, that is root 3. So root 3 happens to be the refractive index of the medium or that glass plate. Okay. Hopefully this particular solution is clear to you all. Now let me move on to third question now. Third question, velocity of light in glass whose refractive index with respect to air is 1.5 is 2 into 10 raised to 8 meter per second. And in certain liquid, the velocity of light found to be 2.5 into 10 raised to 8 meter per second. The refractive index of liquid with respect to air they are asking. Okay. Now glass refractive index they have given. Okay. And velocity of that particular light in the glass they have given, and in another medium they have given. Now here simple task would be, we are supposed to find the refractive index of liquid with respect to air. That's all. So hence I can very easily write this as mu is inversely proportional to V. That means refractive index is inversely proportional to velocity. Okay. So accordingly here I am going to write it as what? Mu1 by mu g, mu L by mu g is equal to Vg by VL. That's all. Very simple. Right. So now over here we can say mu L is unknown and rest other quantities I am substituting. Mu g is 1.5 and Vg is 2 into 10 power 8. Then VL is 2.5 into 10 raised to 8. So very clearly we can get the value of mu L as 1.2 here. Okay, so 1.2 is the refractive index of that liquid with respect to air. This is the absolute refractive index. That's all. Okay. Now let us progress to the next question. Now. Question number 4. A ray of light passes through 4 transparent media with refractive indices mu1, mu2, mu3 and mu4 as shown in the figure. The surfaces of all media are parallel if the emergent ray CD is parallel to the incident ray AB. We must have. Okay. So very clearly, as you can see here, emergent ray CD is parallel to incident ray AB. This clearly indicates that suppose AB medium, if I take angle of incidence here, then angle of emergence in this particular medium, this angle will again be same. So that means I equal to E here. Angle of incidence is equal to angle of emergence. Then only these two can be parallel. No? So this clearly indicates that since the rays are bent equally with the normal, so that means both the mediums must have what? Same refractive index. That means mu1 and mu4, both of them must have same refractive index. So hence I can go ahead with option D as my right choice. Okay, so this is what I have mentioned here. So hopefully now you have understood what I meant here. Okay, now let me move on to next question. Question number 5. Now, a ray of light is incident at the glass water interface at an angle I. It emerges finally parallel to the surface of water. Then the value of mu g would be. Now, here the preparation would be like this. Now, here we have very clearly angle of emergence as grazing emergence, that means 90°, right? So we are supposed to give a linkage between water, glass and air, that's all. So that is what we are supposed to do here. So accordingly, in the first step, I'll write for glass water interface. Okay, so I'll write refractive index of water with respect to glass, because if you just notice here, firstly the light ray is incident from glass medium entering into water medium. So that is why I'm writing refractive index of glass water with respect to glass. Is it not? Okay, so this I'll take as my first equation. Okay, then apparently next, what from water, now it is going to enter into air. So for water air interface, I'll take this as what? Sin r, because r is the angle of incidence between air and water. So that is r sin r divided by what is the angle of refraction? 90°. So hence I am taking it as sin 90° here. Okay, so clearly I'll get this as what? Sin r. Okay, now let us go ahead and multiply these two. Now if we multiply these two, clearly sin r gets cancelled off, is it not? So then from this I can write mu wg into mu aw is equal to sin I. Okay, so accordingly from this I can very easily write mu g is equal to 1 divided by sin I. Okay, so hopefully you understood this. Now here I can write this as what? Mu w by mu g, that is mu wg into mu a divided by mu w for second part. Now mu w cancels off, then we are left with what? Mu a by mu g is equal to sin I. But remember, refractive index of air is what? 1. So hence I'll get this as 1 by mu g is equal to sin I. Okay, so therefore from this I can very easily write like this: mu g is equal to 1 by sin I. Okay, now let me move on to next question now quickly. Question number 6. The ratio of thickness of plates of two transparent mediums A and B is 6 is to 4. If the light takes equal time in passing through them, then the refractive index of B with respect to A will be. That's all. Okay. Ratio of thicknesses they have given, plates. So accordingly, first step. Now I'll make use of time t, time taken by light to travel through a medium that is having thickness x here. X is the thickness. Then from this I can very easily consider this as t is directly proportional to x, because mu and c are constants. So thus I can write this as what? T1 by T2 is equal to x1 by x2. Now x1 by x2 is given to us, so that is what we'll get in the next step. So thus I can very easily write this as, it is taken to be same, right? Okay, now let me just clear this up. As you all can notice here, from this I can notice that Just 1 minute. Here I can notice that what mu is inversely proportional to x. That is what I have applied. So mu b by mu a becomes equal to xa by xb, that is 6 by 4, which is nothing but what? 3 by 2. Okay. So thus refractive index of b with respect to a is what? Mu b by mu a. So that is what we have obtained it as what? 3 by 2, which is nothing but 1.5. Okay. Now this was the solution that we were looking for. Now let me move on to the next question. Seventh question. A ray of light passes from vacuum into a medium of refractive index mu. The angle of incidence is found to be twice the angle of refraction. Then the angle of incidence is, okay, from vacuum into a medium, okay, then angle of incidence I is given as 2 times the angle of refraction, 2r. That is what they are saying. Okay. So now, hence we can write this as mu is equal to sin I by sin r. That is Snell's law. According to Snell's law, we can write it like this. Then, accordingly, I can write sin I as what? 2r. So sin 2r I will get. Okay. So sin 2r can be expressed as what? 2 sin r into cos r divided by sin r. So here sin r cancels off. Then we are left with what? 2 cos r is equal to mu. Is it not? So thus I can write r is equal to cos inverse of mu by 2. Right. So here I can write this as what? Cos r is equal to mu by 2. So hence r becomes equal to what? Cos inverse of mu by 2. And in the last step I can write hence I is equal to what? 2 times of r. So therefore I can write it as 2 cos inverse of mu by 2. Now this is the answer that we are looking for. Okay. Hopefully this part is clear to you all. Now this is the last question for the day. A ray of light falls on the surface of a spherical glass paperweight, making an angle alpha with the normal and is refracted in the medium at an angle beta. The angle of deviation of the emergent ray from the direction of the incident ray. Okay, so they are asking us to find the angle of deviation of the emergent ray. Okay, so let us take a look at that now. Now this is what we have. Now here is angle of incidence. I am taking it as alpha. Okay, then since it is spherical glass weight, paperweight, so obviously we can see that the ray after refraction from first spherical surface will be refracted parallel to the diameter of the sphere. So hence I am considering the refracted ray in this way. Okay. Then this refracted ray will be incident at point C on the other surface. So there again it is emerging out. Since the ray is parallel to refracted ray is parallel to the diameter of the circle, for that reason angle of emergence once again it will be equal to what? Alpha here. Okay. Then again refraction angle from first surface, if I take that as beta, then clearly the angle of incidence at the second surface will again be what? Beta, is it not? And if I consider this whole angle, that is angle MBO, okay, angle MBO is equal to what? Alpha, is it not? So I'll just mention this angle MBO is equal to alpha. Therefore, angle CBO should be, CBO is beta here, then remaining angle MBC will be equal to what? Alpha minus beta. Similarly, angle MCB will be again what? Alpha minus beta here. Okay. So accordingly, if you just consider this diagram, now angle of deviation, how to find that? Now you just produce this angle of incidence further up to m. Okay, then produce this emergent ray backward till m. Okay, then this angle of intersection between incident ray and emergent ray, that is marked as what? Delta here. Okay, so this is angle of deviation that we are supposed to find. And as you can notice here, this delta happens to be an exterior angle of triangle mbc. MBC triangle, to that there is an exterior angle, and this exterior angle is delta here. So that gives you a hint of solving this hopefully. Okay, so now hence I can write this as triangle BOC is an isosceles triangle. I have explained to you why it is isosceles already. Okay, then accordingly angle OCB is equal to beta and emergent angle is alpha. This also I have already explained to you. So clearly from this I can say that in triangle BMC, sum of two interior angles should be equal to exterior angle. That's all. So sum of two interior angle in triangle BMC, alpha minus beta is equal to exterior angle. What is the exterior angle here? Exterior angle is delta. Okay, so thus I can comfortably write this as delta is equal to alpha plus beta, that is equal to 2 into alpha minus beta. So delta is equal to 2 into alpha minus beta is the required answer, my dear students. So hopefully this answer solution is clear to you all. This diagram, I think it is clear to everyone, but you should remember one trick here. Always remember, whenever ray enters from one surface of a spherical refracting surface, okay, sphere, on surface of a sphere, then the refracted ray will be parallel to the diameter, because we should always consider the minimum deviation case. So for that reason we'll consider refracted ray BC is parallel to diameter of the sphere. Okay, if you consider like that, then we will get an isosceles triangle. Okay, here, and angles of refraction at first surface and angle of incidence at second surface, both of them will be equal from this particular assumption, and this is the assumption that you should always have and you should always practice in this way. Okay, hopefully my today's discussions are quite fruitfully helpful to you. Okay, so I will meet you back in my next session with few more interesting questions from Karnataka CET question papers. Okay, so let me just sign off from today's discussion. Me, your physics educator on Unacademy YouTube live platform, Uttam Kumar, signs off from this particular session. Thank you very much. Have a wonderful time ahead. Bye bye.